Okay, so this is over chapter 6, the periodic table. This is a pretty big chapter, and we learned a lot over the periodic table and how to identify all the different levels and sub-levels, and playing Battleship towards the end was a big help because I had no clue how to play this until we played it in science. Okay, so first over chapter 6-1, which is organizing the elements. In 1916, a self-service grocery store opened in Memphis, Tennessee. Shoppers could select items from shelves instead of waiting for a clerk to gather the items for them. In a self-service store, the customers must know how to find the products. From experience, we know that products are grouped according to similar characteristics. For example, you don't expect to find fresh fruit with the canned fruit. With this logical classification system, finding and comparing products is easy. We learned how elements are arranged in the periodic table just like the fruits, and what the arrangement reveals about these elements. So the elements are formed logistically and how we find them. And in this periodic table, the elements are arranged in order from increasing atomic number. One way to classify elements in the periodic table is as metals, nonmetals, and metalloids. This will help you when trying to classify the elements and finding them. Then in 6-2, it was classifying the elements. So actually picking them out and knowing what the elements are and realizing how we use them in our chemistry so we are aware. There was a sculptor who designed a gold coin at the request of Theodore Roosevelt. President Roosevelt wanted coins minted in the United States to be as beautiful as ancient Greek coins, which he admired. The coin is an example of a double eagle. The name derives from the fact that the coin was twice as much as a $10 coins, called eagles. A coin may contain a lot of information in a small piece: its value, the year it was minted, and its country of origin. Each square in a periodic table also contains a lot of information. We learned that the types of information are usually listed in a periodic table. So just like the coin, each square contains a ton of information in this little piece or this little square. And I like using the connecting to your world because it helps me know logic and kind of connect to make me understand them better. So just like in the little squares, so here are some examples like the magnesium, the sodium, the arsenic, and the sulfur. Those are different squares in the periodic table that you find, and this tells the information and the compounds, and it's just really helpful to know more information about the periodic table and what is in them. And about the periodic trends. And an atom doesn't have a sharply defined boundary, so the radius of an atom cannot be measured directly. There are ways to estimate the sizes of atoms. One method would be to take a solid that is bombarded with X-rays, and the paths of the X-rays are recorded on a film. When looking at the photo, sodium chloride produced the geometric pattern. Such a pattern can be used to calculate the position of a nuclei in a solid. The distances between the nuclei and a solid are an indication of one size of the particles in that solid. This section, we learned how properties like atomic size are related to the location of elements in the periodic table. So here's a picture of the atomic radius of H2. In this diagram, it shows that the atomic radius is half the distance between the nuclei of the two atoms. It is the same element when the atoms are joined. So that shows how that is in relation. And then just an overview. In 6-1, we learned how the chemists use properties of elements to sort them into groups, how the modern table elements are arranged in order of increasing atomic number, and 3 classes of elements which are important are metals, nonmetals, and metalloids. In section 6-2, we learned that the periodic table displays the symbols of names of elements along with information on the structure of the atom, which is very important and key. The periodic table can be divided into 4 blocks, which are S, P, D, and F. They correspond to the highest occupied sublevels and atoms of the elements. And in 6-3, we learned in general atomic size increases from top to bottom and decreases left to right, which I wouldn't have known unless looking at it carefully, and this has taught me a lot. And then positive and negative ions form when electrons are transferred between atoms, and first ionization energy tends to decrease from top to bottom within a group and increases left to right across a period. So that is an overview of chapter 6. And yeffers.